Hello again, students. This video, we're going to talk about the real number system. We're really going to focus on rational numbers and irrational numbers, but I wanted to give you an idea of what the entire number system looks like. So I think this diagram does a pretty good job of that. So inside this orange rectangle, all of these different sets of numbers inside are considered real numbers. So I'm going to start from the outside and work my way in. So real numbers are really comprised of irrational numbers and rational numbers. So irrational numbers are on the outside of the purple circle. Rational numbers are anything inside the purple circle. So that involves fractions, it involves any decimals that repeat, it involves any decimals that terminate, that just stop. That also involves integers, so positives and negatives, no fractions, no decimals, but integers, whole numbers, which are 0, 1, 2, 3, 4, 5, and so on, and then natural numbers, or the counting numbers, these are sometimes called. Natural numbers are basically the whole numbers, but no zero. Whole numbers are all the natural numbers plus 0. Integers are all the whole numbers and natural numbers and the negatives of those. And then again, rational numbers. So in this video, we're going to talk about just classifying numbers between rational or irrational. So rational numbers are numbers that can be written as a quotient or as a fraction of two integers. So integer in the numerator, integer in the denominator. That does mean it can be negative, but it has to be two integers. It can be negative, and the denominator cannot equal 0. So examples of this would be whole numbers, integers, positives and negative whole numbers, fractions, anything that has a number in the numerator, number in the denominator, which are integers, terminating decimals, decimals that stop, repeating decimals, decimals that have a digit or multiple digits that repeat over and over and over again. And then also square roots of perfect squares. Perfect squares are 1, 4, 9, 16, 25, 36. The list keeps going. Perfect square basically means you can take the square root of it and your answer is a whole number. For instance, the square root of 25. Square root means what number multiplied by itself gives me this. So in square root of 25, what number multiplied by itself gives you 25? That would be 5. So 25 is considered a perfect square because when you take the square root of it, you get a whole number. So any square roots of perfect squares are rational. On the flip side, irrational numbers, the exact opposite, a number that can't be written as a fraction of two integers. The most famous example is pi. Pi is an irrational number. The decimal form of pi goes on and on and on, so it does not terminate, and it also does not repeat digits. Square roots of imperfect squares, so numbers that are not perfect squares. 31, for example, 22, those are not perfect squares, so the square root of those numbers would be irrational. Any decimals that do not terminate or do not repeat, much like I mentioned for pi, are irrational numbers. And then fractions with that should say a denominator of 0, let me fix that, with a denominator of 0 are also considered irrational. So dividing by 0 results in an irrational number. So we're going to take a look at some examples. We're going to classify rational or irrational. I'll do my best to explain also. So 4/5, it's a fraction. That is rational. Integer in the numerator, integer in the denominator. -6.3 with the bar on the 3, meaning the 3 repeats. That is a repeating decimal. That is rational. Pi, irrational. Probably the most famous, most common irrational number. Square root of 81. So we have to think, is there a number that when we multiply by itself, we get 81? And there is. It's 9. So square root of 81, that's a perfect square. It equals 9, therefore rational. 6.73. It stops, it terminates. This decimal is rational. Square root of 26. Anytime we see the square root, we're thinking, is there a number that I can multiply by itself to get 26? There is not. So this is irrational. 26 is an imperfect square. Square root of an imperfect square is irrational. 5 2/7. It's a mixed number. Could be written as a fraction. We could do 5 times 7 plus 2. That'd be 37/7. Rational. Positive 6.63 repeating. The 6 and the 3 repeat over and over again. If we were to extend this decimal would look like this, where the 6, 3 just keep repeating. Repeating decimals are rational numbers. Square root of 71. Is there a number that when you multiply it by itself, you get 71? No. So it is irrational. 1.752 with the bar over the 752. That means the 752 repeats. Repeating decimals are rational numbers. Negative 1.5. Negative doesn't mean anything, and negatives are rational numbers. 1.5, it's a terminating decimal. We could write this as -1 5/10, which would simplify to -1.5. We can turn that into an improper fraction. It would be -3/2. Therefore, we can write it as a fraction. It is rational. So this video was intended to help you just classify a number as rational or irrational. I hope this helps with your assignment today. If you have questions, please feel free to email me. Otherwise, have a great day.